Okay, so yeah, so we record the lectures and then I'll post them. So yeah, so okay, yeah, so we got a Canvas problem that I'll get solved as soon as I possibly can. I think you just need to click publish. Ah, see, maybe now it's going to get solved. So if I go down into courses here where I'm at, and then I say, publish. Yeah, I bet that did it. All right, pages. So I'm going to go through and I'm going to publish them all. Good point. See, it is much better. If can I maybe do it all at once in one fell swoop? No, I can't. I have to do it kind of on a, all right, material, publish, pages, project list. Let's get that published, pages, and then let's get projects. Let's get that published. And then let's go here and let's say pages and then recitations and let's publish that. All right, so no, publish, published. Okay. All right, guys, now it works. Make sure, could someone just like put something in the chat if I didn't get them all, because I might have maybe missed one of the pages, like maybe I missed, I'm thinking maybe I missed that one. Yep, see, now that one's published. Okay, all right, back to the home. Okay, so now we can start. And these pages aren't going to change very much. I think maybe when I edit them, I have to republish them or something, but just we got that cleared up here. All right, yeah, so I'm new to Canvas, so that's the reason why it's been a little bit of a rough start here. All right, so let me just share my screen and we can all see this. And of course I'm watching in the I better do this. Good. Just give me a share screen. So stop share. I'm going to share the different screen. Make it so that I can actually look at you guys. All right, share screen. And then we share. Let's go right there. Talking. Yeah. No. I want to pin this one. All right. Anyways, I guess you guys can see the full screen right here, but you can't see like my mug, my face. Can you? Can you guys see my face? Timing and topic is locked. Is it still locked? So if I go to pages, okay, good, it's fixed. All right, home. Okay, sorry about I don't like wasting time, but I just did. Can you guys see my face, or you just see the screen? Okay, do you see the screen and the face, or do you just? Okay, good. So good. So it's recording, because we can't leave out the face. Sorry. All righty, right. So welcome to 5DV187 Database System Principles. The course is a continuation of 5DV202, which is the introduction to databases. And of course, you might say that, Michael, why is it that the introduction has a larger number than the advanced? And I don't know, but I think it's there's some humor in it. How many guys, let's get a show of hands here. How many people actually had me for 5DV202 introduction to databases? Can I just see a show of hands on the participant list? Put your hands in the air. Okay, got one. All right, good. It looks like we can see these quick polls here. All right, 6 participants now raised their hand. It's got to be more than that, 7. All right. I think maybe the better question, so everybody put your hands down. The better question is, who did not have me for the database 5DV202? Who did not have me? Okay. All right, and I'm assuming the people who did not have me, since I've been teaching that database for a while now, I'm assuming that's because you're starting here in Umeo, you're an exchange student or something like that, or there's some other reason, and that you actually have had like a database introductory database course, because that's definitely necessary here. We're going to assume that that everybody's has databases 101, as it were. Okay, so so this course is, I guess if I had to just say it, I'm going to also kind of read off verbatim here. It's kind of the boring way of doing it, but let me just do it. This course gives you insight into techniques that underpin modern database systems as well as their application. It's an advanced database course in the sense that it's kind of like we're delving deeper into how databases really are implemented. So it's kind of like the database system side of things. So, how do these actually get built? And then also, like, what are a lot of the modern applications, like the for real applications of databases? Because one thing we know about databases is that they are definitely for real, in a sense that the economy in large part is more and more based on databases. So it's like it's a moneymaker, as it were. All right. So so specifically, we're going to look into the data structures and algorithms that support efficient data access, query optimization, and transaction processing. Okay, so transaction processing is going to be a big part of the course. The course also introduces data warehouses, data extraction, data exchange, and a potpourri of emerging technologies. So that will kind of come out. Okay, so students. Okay, so here's the thing. Students are going to explore your own particular interests in these fields through student-initiated group projects. Okay, so one of the main parts of the course is a project. All right, it's a database project where you really take the commanding lead over that project and you develop something and then demonstrate it for the rest of us. All right, so we'll get more into that. So course content is covered in a series of slides and mandatory readings. All right, mandatory readings. Yeah, so I really do kind of expect you guys. I'll be more specific about this in a bit, but I really want you guys to know something at the end of this course deeply. And what that something is our friend PostgreSQL. So this kind of, you may not like it, but you're going to have to understand. You're going to have to read the PostgreSQL. I mean, I want you to be an expert at PostgreSQL by the end of this course. All right. And you might say, well, that's kind of, I don't want to do that. I mean, what a waste of time and money that is. But that's not true, because you can make a fortune with PostgreSQL. PostgreSQL is like the database now, right? It's one of the major databases on AWS, Amazon Web Services, or AWS is Amazon Web Services, and also on lots of the other cloud platforms. So it's definitely, PostgreSQL is definitely something that we want to rally around. And based on that, I mean, I'm going to be a little more specific, but really, I'm really going to ask you guys to suck the whole thing down. Anybody got a problem with that? I mean, I want you guys to be like pros at PostgreSQL by the end of this course. All right. Okay, good. This is also a nice mandatory reading, because this kind of gives you an idea a little bit. This is very, very. This is kind of shows a certain use case that's very wide-ranging use case of databases, and kind of how they're really being used in industry now. And so I want you guys to read this as well. All right. So those are the two main mandatory readings. I might add some other stuff in here, and then of course there'll be optional stuff, and maybe material will be readings and some videos and stuff like that. Okay. So PostgreSQL is going to be a main focus. So what is PostgreSQL? I mean, okay, I'll just ask, has anybody not used PostgreSQL ever before? I mean, I know I put you guys on the spot. All right, some people. All right, for those people who raise their hand who haven't used it, what database have you used? Maybe you can put that in the chat if you want. Okay, yeah, I got somebody, MySQL. Yeah, okay. So, well, anyways, these are the other. Yeah, I mean, it's, let's see. So I have a question. Will you be posting the chapters to read in the book? All right, when you talk about the book, are you talking about the database, I mean, the textbook officially for this class is the Stanford database, the complete database book. But when it comes to PostgreSQL, yeah, I'll be being a bit more specific about what needs to specifically be read. But really, if you want to start, just start reading the whole thing. Okay, the database book. If you're talking about like the database textbook from, we're not really following that verbatim. It's kind of implicit in what we're doing, but it's not. There's not going to be any assigned readings from the database textbook. That is, let me see if I can grab it here. This thing. No. By the way, so I think this is like the best textbook in databases in year like 2014. The best textbook in year 2014. Absolutely. And what does that mean? It means it's also the best textbook in year 2021 because the database textbooks have fallen off a cliff. It's not the way things get done anymore. It's all it's all kind of on the web now, and things are moving so fast in databases. Things are moving so fast in databases. I don't think anybody's really taking the time to really document it in textbooks. As far as I can tell, I haven't found a good textbook, and the Stanford people have kind of like with their Coursera and all the other stuff, it just seems like this kind of dissipated. So textbooks are maybe on the way out, I'm afraid. I like reading though, but in this case, though, there's a lot of reading to do in this course. There's the PostgreSQL documentation, PostgreSQL. So PostgreSQL, I've heard it explained this way: if you took a VW Bug, the VW Bug, that car, and you put a Porsche engine in a VW Bug, that's your PostgreSQL. Okay, so PostgreSQL is kind of might not have a very finished like outer exterior like a VW Bug, but under the hood, it's like a Porsche. Okay, it is really it's got muscle. I mean, the PostgreSQL is supreme. Now you might say something like, "Oh, there's other ones," and we'll talk a little bit about the other commercial ones. But PostgreSQL is what we're going to focus on. Now I see that some people did stuff around MySQL, and some people actually say that they. So MySQL is pretty good, I guess, too. I mean, there's MariaDB, there's MySQL, kind of the same thing now. Well, people know the story of that. For the projects, you can use MySQL if you want. You can use, but I really want us to focus on PostgreSQL in terms of like the recitation. So let's get back to the structure of the actual course here without me just raving. And I spend like the whole course raving about PostgreSQL and never get anything done. All right, let's get back to it. All right, so boink there. Yeah. All right, so the course consists of, I think, 8 lectures now. Maybe it'll be 9 at the end. 4 recitations, 1 makeup recitation, a short quiz, and a couple of meetings covering student projects. All right. The timing and topic of lectures is posted here, but is subject to change. So this is the structure of the course. This is kind of how it's going to operate. I called in, let's just verify that this is out of time minutes. So this September 9th, is it September 9th? No, it's September 10th. We're not going to have a lecture on that on September 9th. But basically, today we're going to introduce the course and we're going to do a little SQL review. Then we're going to be doing kind of advanced SQL and warehousing, and then maybe more focus on PostgreSQL and kind of give a kind of sweeping kind of coverage of SQL in the beginning, just as a kind of review, and kind of a little bit about warehousing to kind of get you guys to understand that a little bit. And then we're going to have recitation 1. So for those people who had me in the database 1 course, the recitations, you should be familiar with what a recitation is. So what a recitation, and I'll explain, but I'll go ahead and explain here. So we're going to have 4 recitations. We're going to have 1 that's going to be kind of on, maybe I'll go to the page. Home. And let's see, recitations. All right, so we're going to have a kind of a database review and advanced SQL recitation. So the way it's going to work is I'm going to give you guys problems 1 week ahead of time, and it'll be 10 problems. And then what you're supposed to do is you're supposed to do the problems on your own. And I mean, on your own, you. Uh, and then what happens is when we have the recitation, I have you guys sign up where you declare what problem you can do. When you declare what problem you can do, then I will, let's say, for instance, 20 of you say, yeah, I can do problem 1. And then 20 of you say, I can do problem 2. And I'll have like a system where we can automate this. So you answer the poll before the recitation, and then I will randomly select on people to present their work. All right. But if you claim, like, let's say I claim all problems, I can do all 10 problems. And then as the recitation progresses, Minak never called on me. Well, you get the points, but you run the risk of being called on. And when you're called on, you got to present your solution. All right. So does that make sense? Like how recitations work? So basically, you do the work beforehand. I want you to upload because I have to figure out how we do this in Canvas. I was using Cambro before, but now I'm kind of hopping off of Cambro. So I'm going to do everything like I did on Cambro on Canvas. So you're going to upload your material, so I can at least check to see that you actually did do the work if I need to, and then you're going to basically be on call to present. Yeah, see that we already have a positive review of recitations. Yeah, I think recitations are good because the thing is, one thing is for sure, and that is that you guys are going to be so sick of hearing my voice kind of scratching along, and it's nicer to have you guys speaking than me. So, but yeah. So those are recitations. So recitations are kind of a treat in a way because they, So we're going to have one on advanced database. We're going to have one on database tuning. And the idea here is that I want you guys to like set up indexes so that you can make things run quickly. So to make your queries more efficient. How large are the groups we do recitations in? It's a group of 1. That is you. So you got to stand on your own on these recitations. So basically, when I call on your name, it's going to be like you can't like grab somebody else and have them present for you. You're kind of you're responsible for the work individually. All right. We'll have one on database tuning, and then we'll have one on transactions. And then I think this will change here, but one on basically this is kind of like on data extraction from text. But number 4, I might change a bit. I'm not really sure. But we'll cover it when we cover it. So but basically the way it works is that when we look at the timing of the course, what we have here is we have it so that you're always going to get a 1 week. So the material gets covered, and then you get like a week before, and then of course on September 7th, recitation gets handed out, and then you have a week to work on it, and then you do the presentation. Same thing here where we're doing query processing, indexing. So this is kind of more on performance stuff. This is where you're going to be doing this trying to speed up queries. Look, I mean, you guys can work in groups. I can't police that. I mean, if you guys want to talk to one another and kind of and work together, yeah, within reason. I would prefer actually you don't do that. Actually, I'm not going to say, oh my God. I mean, but I don't want the work to look the same. Let's put it that way. Everybody's got to present a fresh solution. If I go through and I see that it's the exact same solution, like 7 people are sharing the exact same solution, no. That will that's a violation of the honor policy. If you pick one other person, maybe I'll write this down because I need to kind of, I don't want you guys to be bred to be antisocial. But then again, I believe in antisocial. I think it's important to be not antisocial, I'm putting it in the wrong terms. The point is that really ultimately with technology type stuff, you got to be alone and it's just you in your head and not rely on somebody else. Who are they? Look, no, I want everything to be individual. But you can talk to each other. Here, you can talk to each other. I can't block that. What am I supposed to say? You guys can't even speak to one another? But I want the solutions to be different. So, look, you'll have your whole career to work in groups, all right? I want you to work individually. And if you want to make big money, you should learn how to work individually because that's how you make big money, by being an entrepreneur. And that a lot of times means individually. All right. Okay. Let's see here. All right. So yeah. So we'll do one on transactions, and then we'll do this kind of semantic web node structure. So it's all set up that way. Okay. Let's get back to let's kind of get moving here on this. This is okay. Okay, short quiz. So there is a short quiz, which is kind of like well, I'll talk about it in a second. Okay, the timing type of lectures, blah, blah, blah. Okay, the entire course will be held on Zoom. Yeah, as we know, COVID is still romping around, so we have to do everything on Zoom. Time edit. I just want to make sure that they actually made the change. They may not have made the change, which is annoying. It's quite annoying. This is canceled. That will not happen. Is there any way I can get in there and change that? And the answer is no, because I tried to. But I sent a mail to them saying, please remove. And that was like a week ago. All right. But, you know, I'll send out reminders. If they don't remove it, then they don't remove it. The slides for the lecture will be posted here after lecture. Okay, so here, I'll be putting the slides here and the video links here. Okay. Describe. Recitations I've already described. The rules were, okay, these are still subject to change, I'm afraid. But here's what I want you guys to do. I want you to now in this case here, you do have to work in groups. So you might even start doing now. I want I want you guys to found your group by you still have a lot of time here before you have to do this, but maybe it's me, you can do it now, right? But I want groups of 3 to 4 students. If you pick a group of size 3, I reserve the right to kind of to take a straggler and shove them on your group, right? An extra person, okay? Randomly assigned. The way it'll work is that you'll have 4 groups, and then basically we'll have a 15-minute meeting on the 24th. So I will meet with each group for 15 minutes, and we'll bounce around ideas. I want to hear kind of what you guys are interested in doing. And then over the next week, hopefully we'll get a specific proposal developed. So then we'll have a proposal developed, and you'll have to send this. This is kind of just, when I ran this course at KTH, I had so many students, I had to kind of make things kind of really formal so that to kind of keep efficiency high. But let's just stick with it. Yeah, so just follow this. And then I'll be listing the projects here, but this course is empty at this point. We don't have any projects. Then we're going to have some midway meetings. So we're going to have meetings where I'm going to come in kind of like, almost like, think of me as like kind of playing the role of an investor. Coming in and kind of, you know, find out, well, you know, I just invested, you know, $1 million in your project here. And, you know, what's the status? What do you guys, you know, are you moving towards completion or what? All right. So consider it to be like kind of that kind of, that's the kind of the mood of the midway meeting and the final project meeting as well. Now the presentation phase, you're going to develop a video, and the video, this is kind of important. The video, the first part of the video, it can be actually, doesn't have to be very long, but it's got to be like a commercial. I want you guys to put on, I mean, because you're going to have to wear a lot of different hats in this. Well, you don't have to, but most likely you're going to want to wear a lot of different hats in your career. So we want to pretend like this is actually, you're actually trying to make something that you can sell on the market. All right. That's what your project is a product, right? Then you're going to have a 5-page report and then a zip file. I'll come into some more of these details later. Yeah, and then we're going to have the final grading phase of the project. All right. So, but the idea behind the projects is, of course, they're going to use database type concepts, etc., and you're going to develop a product. Okay, that's supposed to do something. That's like solving a problem that people have, all right, that you can sell and make money off of. Right, that's kind of does that make sense? So it's not like, so we don't want to study of like, oh, let's compare. No. We want like product, all right? Everybody clear on that? All right, it'll become clearer later, and we're gonna tussle. We're gonna have like, it's gonna be fun. We're gonna have a lot of back and forth. All right. Okay, let's go here, pages. All right, not pages, let's go back to this. All right. Okay, at the very end, there's a quiz, which will be simple variations on the recitation problems. All right. So the quiz, it'll run the quiz as an online quiz. It's only, you know, well, I'll show you the points in a second, but basically it's kind of a refresher at the very end to kind of to make sure that you kind of, something stuck from recitation. Okay. All right. And here's the grading policy. So the grading policy. All right. First of all, this course is divided into, this stuff is always so boring for me. But this is the way it is. All right. Is the exam going to be online? Online. It's going to be online. Absolutely online. I mean, I'm assuming I can run an exam. I know I can, because I saw a link for it. I can run quizzes. I can run an exam through Canvas, just like I could through Cambro. So it's the same kind of deal. It won't be, it won't be like a giant deal. It's just more to kind of, it's kind of more of a safety check at the end, just to kind of make sure that you guys go back and review your recitations. All right. And it will be open book. So, because I can't make it closed book because it's online exam. All right. So each recitation is worth 100 points. And then the quiz is worth 100 points. So, that's 500 points total for the principles section of the course. So principles, so we have two moments in the course. We have the principles and the practice. Principles is, it's your recitations plus your quiz, and it's pass-fail. And then the practice is your group project. Right? And the overall grade is a 5, 4, or 3, or a fail. And basically, so the projects are worth 500 points. You got 100 points apiece for the recitations, 100 points for the quiz. That's 500 there. And then you've got 500 points for the project, which basically you have, these are basically, we'll come to the projects later on, the grading of the projects, but there's kind of some different components to that, but it's fairly straightforward. So you need to get at least 250 on each of these moments. Otherwise, you're going to fail that moment. All right. And then we sum up all the points, and then it's going to fall on the scale here, where 900 and above gives you a 5, 750 to 900 gives you a 4, and then the 3 is just about 500. All right. The way this course works is basically to get a 3 or a 4 should not be too difficult. It's kind of like just showing up and doing the work. To get a 5, you have to kind of be a little bit fanatical and perfectionistic to get a 5. All right. So I'm not going to give out 5s like candy. 5s have to be you have to be kind of a fanatic to get 5. All right. Any questions on the grading policy? What are we looking for? Time here. Oh, okay. All right. Okay, then. Definitely send me questions or email. By the way, email, I'm not really sure how it works. There's an inbox here, apparently, where I have no... It's probably best to always, when you want to send me email, just send me email at mjm@cs.com. Yeah. So let's solve that right now. Let's get that solved exactly right now. And boink. And all right, edit, and there I am. And there's me email. Okay, I'll pretty it up a little bit later, but now people got my email. Yeah, that's the best way to reach me, is that email. Probably I'll get like some notification if you send something on Canvas, but send me there. All right, do we have any questions, other questions? Any questions? Okay, so let's get right in. Let's just hop right into it then. One sec. Let me just pull this puppy up. Let me go down here and let me go over to here. And then let me do present a slideshow. Okay, so we're going to do a review now of relational databases and SQL. These slides actually came from Steve, who used to work here. So Steve and I, we still, are the other teachers or grades involved with the course? No, it's just me. I suppose you guys are technically able to basically say, we don't want just him. And you can say that, and you can make it like a claim, no, he's annoying or something, and we want another person to grade. But don't do that, please. Or if you do, I'll just say, well, okay, somebody else has to. No, I'm just kidding. It's just me. Apparently, I think if you get failed in a course, that you have the right to ask for a different examiner or something. Yes. Thank you. I you know, it's so you know, I'm blushing. One second, I need a gulp of coffee here. All right. The slides will always be uploaded after lecture. Absolutely. As will the video. If you want to, you know, if you want to have a watch through the whole thing again. All right. Okay. Any other questions? So now we're gonna kind of get down to business here. This is, I mean, enough of this kind of bureaucratic mumbo jumbo. Also, as far as bureaucratic mumbo jumbo goes, I have no idea. I mean, some of you guys are enrolled, some of you guys are registered. I don't know what those things really mean. I think that what it means basically is if you're, well, there's accepted, you can be accepted to the course, and then you can be registered for the course. I guess that's how they want to say it now. I have no idea. Just if you want to take the course. And in the end, if you like somehow screwed up and you were in the wrong status the whole time, we'll clear it up, okay? So just don't no worries on that. Although I think strictly speaking, you're supposed to register if you're accepted and you want to really actually take the course. So just keep that in mind. All right. So all right, let's hop into it. This is going to be a little bit painful because this is not the kind of thing I can really like get the document camera out to work with. We just have to kind of grind through these slides. So let's just grind through the slides, and I'll try to make a lot of different little side comments. All right. So credit to Steve because he's the one who originally formatted this stuff, but we kind of developed a lot. Well, yeah, credit to Steve. All right. Why does that happen? This is annoying. I'm sorry. The stupid, well, it's not stupid, but it's like the, here. I can't read the title because the dumb bar for Zoom. Can I move this thing? Get out of, it moves. Get out of the way. All right, now you can hear me, right? Yeah, I'm muted. I was muted. But can you guys still see my face? I'm probably looking off to the right here, reading the chat. Good. All right, so 3 types of information systems. This is kind of a broad categorization. We have information retrieval systems. This is kind of like Google, where the input, the query, is like a text search, and then what gets returned is like the documents from the search, right? And maybe there's some things highlighted in there. But that's kind of your traditional what's called an information retrieval system, but then Google took that to the web, right? So, you know, it's not really databases, but it's a web search engine. It's like basically doing keyword search over the corpus of documents, which in this case are web pages. And how does Google do it? What's the, I mean, you guys have probably had this in other courses. What does Google use? What's the algorithm? What's the basic kind of magic behind Google's algorithm? What first of all, what's it called? I'm looking in the chat now. What's it called? I mean, you guys should know this. I mean, geez, this is an interview question. If someone says, okay, please give me the name of what's the algorithm behind Google? Somebody's, I mean, what is it? What's it called? No, not that. I don't think so, at least. PageRank, yeah, good. So someone said PageRank. All right, so PageRank. So what's PageRank do? Yeah, I mean, how many people have heard of, seen of, or been presented? How many people have not heard or seen or, you know, PageRank? To them, that's like, what? PageRank? I've never heard of that. Could I get a raise of hands of how many people have never heard that before? Okay, so we got some. Okay. Yeah, you should probably kind of want to know at least just what the term is. Okay? PageRank, what it basically says, I mean, this is gonna, I'm sure I'm gonna butcher this, but basically the way PageRank is or works is that it's like, Well, it ranks pages. And it ranks pages by how many in pointers there are into the page from other pages. So the idea basically is that things that are referenced a lot, quite a bit, by, pointed to by other pages, that those should be higher in popularity. And so that when someone does a search, of the web, those things that have a lot of pointers into them should rank higher than things that are just kind of isolated and don't have any pointers into them. Okay. That's the kind of the motivation. Now the issue then, technically, what is PageRank? PageRank is basically a solving for like this eigenvector, which basically it has to do with like doing a certain model of kind of random visits to websites as you follow links along. And then what's the, and you basically want to have it so that you can solve for, basically you solve for the ultimately the quality, the likelihood that you're going to wind up at as a sink, you're going to wind up at some site web page. So it actually ultimately becomes this large matrix problem, and it has kind of some nice theoretical properties, and that's what PageRank is. Okay, so but we're not going to cover PageRank in this course, but you should at least kind of know a little bit about what PageRank was. So what used to happen, of course, way back in the day, is that you would search for, if you were way back in the day when Alta Vista was the search engine that people were using. You would search for basically something like flights, Umeå, Stockholm, or something, and you get a bunch of pornography pages back. Because what they do, because the porno people, they basically had these sites where they had all the whole dictionary on their site, so it was matching all the keywords, but they were putting white on white background, so you didn't see it. But then the search engines would take them in, index them, and then it was it was kind of a big mess. But I mean, not many people were pointing to these sites, thankfully. So basically, what happened when PageRank came along, it kind of just like cleared away all that bullshit away. All right. So that was a big result, and Google got rich for it. Okay. Although Google made its money by advertisement, which I guess, what was the name of the company that Google took their advertisement model from? I can't remember the name of the company, but this whole PageRank, PageRank was their technical solution, but this whole kind of AdSense, or the way they did the ads and the way they sold keywords, that's how they made their money. And they made money, a lot of it. So anyways, it's going to bother me what was the name of that company that innovated the AdSense, the AdWords stuff? It wasn't AdSense. It was something before that. Anyways. Okay, so that's one type of information system. It's called an information retrieval system. Okay. Then we have data. So basically, it's just a bunch of text that gets indexed. All right. And we'll talk a little bit about this at the end, because we're going to do some text search stuff at the end of this course. Because we'll see. All right. Now, database management systems, which all of you guys are familiar with, basically have a relatively small schema. So the number of concepts or number of tables is relatively small. And then you have just a large body of homogeneous data. So these records that are kind of in this nice form, and you have a lot of them. Okay. You have limited deductive capability, and you have an extensive way to do updates. So you can update this data and kind of, and you can manage it for both read and writes. Okay, so it's really kind of like, yeah, this is where you can kind of like put information in, pull it out, and it's in a very structured way. Knowledge-based systems, those are things that are much more kind of keyed around like a specific kind of AI type task. All right, and knowledge-based systems is an old way of calling that, but basically what those are is they generally have a small body of kind of heterogeneous information that's very, very particular to the what's being modeled there, and they do a lot of deduction. They do a lot of deduction. Now, a lot of machine learning stuff kind of can kind of fit into the knowledge-based paradigm now in some sense. Now, what's happening, of course, is that databases are always hungry, and databases are very imperialistic. They always want to extend their empire over larger and larger, information. So databases are currently basically in this kind of, they're expanding out again. And when I say databases, I'm talking about relational database systems are again on the march to kind of suck in the information retrieval systems and also knowledge-based systems. So again, databases and the relational databases in particular are highly imperialistic, that they want to like kind of subjugate other types of systems. Right. So we got a question here. What does homogeneous data, heterogeneous mean? So homogeneous data basically means it's all the same structure. So homogeneity, from database point of view, homogeneity is good because it means that everybody, like if we had like a set of contacts or something, they got a name, they got an email, they got an address, they got a city, and then we have 20 million of them, right? That's homogeneous because they all have the same structure and it's a lot of it. Heterogeneous is that if you just have lots of different, oh, I have some data over here in this weird format, I have data over here in this weird format, that's heterogeneity. And generally speaking, we don't like heterogeneity. We want to uniform and kind of just put things down to a standard, across data. So the world is by definition, but the world itself in itself is heterogeneous, of course. But we're trying to kind of like squeeze that out and uniform things. Okay, good. All right. So, multi-user relational database systems. Okay, so of course, in this course, we're going to focus mainly on relational database systems, but with the idea that they are imperialistic and they're pulling in information from people and knowledge base and machine learning type systems. That those are in the sights of databases. Databases are greedy and hungry and they want it all. Right? Okay. PostgreSQL. Okay, so the open source systems, the big ones, I would say, are PostgreSQL, MySQL, and SQLite. So I guess a lot of people, everybody in this course, is there anybody who has no experience? And I mean, you probably don't want to raise your hand. Although actually there is a person who has their hand still raised that probably wants to put it down, especially after I ask the next question. There's still a hand up. All right. Is there anybody who has not used either PostgreSQL, MySQL, or SQLite? Put your hands up if you have not used any of those. Okay, I think that one hand that was up was already up. So that's good. All right, so everybody's got at least a taste of one of those because, yeah, these are, yeah, and then there's these other three which are just, what is this? IBM Oracle database. I mean, yeah, you want to spend that kind of money? Well, actually, if you're a big bank, maybe you do, because Oracle probably does some stuff. All right. Oracle's for real for certain types of applications. Yeah. I mean, if I was starting a business, would I use Oracle? No. DB2, same thing. Yeah. All right. SQL Server. Yeah. Well, it's got this. Have people heard of Power BI? Power BI. So I mean, the Microsoft platform, they're kind of building some stuff on there that some people kind of get locked into. But is there? I mean, could you go your whole career without even touching any of the commercial ones now and just work on the open source ones? Yes, definitely. In fact, I would recommend it. Okay. Let's see. All right. 1 second. I just gotta. Hey, jag kan ringa tillbaka i 5 minuter. Yeah, hi. Okay, maybe that was a hint that, let's see what we're going to go on here. Okay, yeah, this is probably a good place to leave off. Yeah, so we're going to take our 15-minute break now, but the thing I was going to say just basically is that from our points of view, there are a lot more SQL engines out there. This is a big list. It's a giant list. I'm sure that, can anybody think of anything that's not listed here? I'm sure you can. I can. There's a lot of database systems that are not listed here as open source relational database systems. Yeah, I mean are there any other commercial ones? There's one that's actually quite nice, actually, that I would recommend people might even want to look into, and that's called Cockroach DB. Cockroach DB is actually might be one of the. I'm not really sure what they were building on top of, but I'll leave you guys with that Cockroach DB. That's worth looking at. Okay, let's take our 15-minute break and be back at 11:15. Okay, you can put any questions in the chat if you want. Okay, I'm going to pause. I wonder if I pause, does that stop? Yeah, it's going to. Of course, it'll stop recording. Okay, I'm going to pause and resume at 15 after. Okay, recording. I hope it's recording. Yeah, it's recording. Share screen. Share. Okay. You guys hear me? Yeah, good. All right, so let's continue on. By the way, I will actually, because I was requested, I will upload slides before lecture. I was trying to do it right now, but I ran into some difficulty. But I, get the bugs worked out of Canvas here for me. All right. Okay. So let's just continue on here. Unless you're again, put in the chats. You can direct message me as well, so you don't have to. It doesn't have to be to everybody. So I keep my eye on. That's why I always look to the right here, so to get feedback. So all right. So this should really be all right. Okay. This really should be review for people. So I'm going to go over this really, really rapidly. So the relational model, the basic way it works is we have tables, and then we have columns. All right. So traditionally, what you have is when you talk about more academic stuff, you talk about relations and attributes. But when you get into more kind of practice, you would talk about tables and columns. So that's more the SQL terminology. Tuples are a row. So primary keys are primary keys. There's a lot more to be said about kind of terminology systems. They go back and forth. So then you have objects and properties and associations. And there's all these things. They always have some kind of correspondence to some underlying relational model, but it kind of depends on the context of which terminology you use. All right. So, anyways, what we're going to use, I'll stick with SQL terminology. So I'll call these things tables, and I'll call them columns, and I'll call them rows. Okay. So we'll sometimes when I'm probably speaking a little bit more academically, you'll hear me say relation, attribute, and tuple. But there's a correspondence there that if it's ever confusing, just kind of make me stop me, and I'll try to kind of get the terminology straight. All right. So anyways, the idea here then is that we have like the schema, and the schema is like the table definitions. And then we have the state of the database, and the state of the database are like all the rows that are in each table. Right. So this is showing us both a schema, and it's also showing us the state of one particular database. So this database here has how many tables? 1, 2, 3, 4, 5, 6, 7. And it's kind of the old, education example where we have departments, courses. It looks like students, instructors, and advisors. All right. So that should be kind of clear. Now, what you should all remember is that we have when you underline something, that you're basically saying that it's going to wind up being the primary key. Okay. So you have the primary key of the, department here, which is the department name. And then you have the primary key of the course, which is the course ID. And then advisor. So right here, this is doing a many-to-one mapping between students and advisors. Okay, so a student can only have one advisor. Therefore, this table here, the student ID can wind up being the primary key. All right. Over here, look at the classroom here. I just want to make a little side comment to people here. Over here, you have classroom, and it has a 2-attribute primary key. So it's like the building and then the room number, right? So generally speaking, you don't, in practice, you don't want to do this. In practice, you want to try your best to have your primary keys be a single attribute. It's just kind of, things tend to work out better that way. So that's just a kind of so you could criticize the design here a little bit because they don't have a surrogate key. They rather have a multi-attribute key here. All right. But that's, maybe some people would argue that, well, we want to keep these like that, but all right. So it's just you get into the design arguments and they never end. All right. So anyways, now this, of course, we have takes here where we have, this is a record of taking. where you have the ID of the student, the course, the section number, the semester, and the year. It's almost certain that in like university, in the university database, like in what is it? I'm just guessing. I'm almost, well, I could go in and check, but in this LATIC, I'm almost certain that they've collapsed this all into a single surrogate key that encompasses all these. I mean, there's like a record ID on takes. I'm almost certain they would do it that way in practice. And certainly with this right here, this teaches, there's going to be, I hope people understand what I'm saying there. This is the database we're given in coming out of Silvershot's book. So this is the database we'll use. But just getting, I mean, in practice, to see like a big, set of attributes here that all form a primary key, that's just probably not going to be a good idea. All right. Section. All right. So it's kind of, we've got a fair bit of database data here. This is the schema, which is just winds up being the names of the tables and the columns or the attributes. And then, of course, in this true schema, we have the actual types as well and some other things. All right, so integrity constraints. So this is really kind of basic stuff. So I hope that there's no questions about this. But the two primary types of primary is bad use there, but the two types of most commonly used integrity constraints are the primary key dependency and the foreign key dependency. All right, so these kind of come automatically in SQL. So what primary key basically says, no two distinct tuples can share the same value. So it's kind of obvious what this means. It means that, like, if we say that the primary key of department here is the department name, it means you cannot have another biology here in a different building. Right? This name is occupied, so we can only have one row with a particular column value for department name. All right? Foreign keys are basically saying stuff like this. So what a foreign key says, there's a foreign key, of course, from advisor here, which is a student. So here's a student, right? And here's the ID. So the primary key of ID, the primary key of student is the column ID. So therefore, none will share the same value there. And then what a foreign key says, it says that if I have a foreign key pointing from advisor to student, which I'm sure it is because it's SID here, then basically what it says here, that 76543 had better be in this table. 76543, good. So Brown was there. If, however, we had 76542, and I checked over here, and there is no 76542, then we have a violation of this foreign key constraint, and we basically have, this is like a dangling reference that points to nothing because there's nothing there represented. So we've basically broken what's called referential integrity, and our database is in a sloppy state. All right. But if we declared a foreign key, the SQL will never let us have that kind of dangling reference. So it enforces the foreign key integrity, right? And that's very important to have that. All right. Right. So those are the two big ones, are the primary key and foreign key dependencies. Those are the really like the foundational integrity constraints in databases. All right. So here this is how we've denoted them here. And you can have some kind of more tricky ones. Like what you're having right here is you have, so this actually is true actually in the way they do scheduling at KTH certainly, and I think at Umeo as well. They have these kind of time slot IDs. So it's like time slot ID A stands for, I don't know what our time slot is here in this course, but they have a time slot that's defined as Tuesdays from 10 to 12 and Fridays from 10 to 12. All right, that time slot ID defines that, so it groups them all together. So you might have a course that's assigned to a time slot ID so that it kind of eases the scheduling problem of courses. But that time slot table, the time slot ID is not the primary key of that table. It's the time slot ID plus the date and the start time. That's what determines the key. But we have an integrity constraint here. We have what's called an inclusion dependency, which says that on a section of a course, if we have a time slot ID, that it had better exist in this table over here. So that's what's called an inclusion dependency, because it's basically saying that if I did a projection on time slot ID from section, and I did a projection of time slot ID on time slot, that there would be a set containment among those the sets that are yielded. Okay, that's what's called inclusion dependency, and an inclusion dependency is a little bit more general than a foreign key dependency, and there is no real universal way of declaring those in SQL. So to actually enforce a inclusion dependency, you need to use something like triggers, all right, which we'll cover in a second. All right, so I hope that if that didn't make sense to what I said to you, let's work on making it so that makes what I just said, that last couple sentences, if that didn't make sense, let's work on making it so that actually it does make sense to you. So, you know. All right. So null values. Yeah, so null values come up in databases, of course, and they can have lots of different meanings associated with them. So a null value is simply that there is no, let's see, do we have any null values in this right here? No, we don't. So let's say that I went in here and I said that, like for instance, right here, introduction to computer science, it's worth 4 credits. But let's say I just kind of removed that because we didn't know how many credits it was worth yet. And I just put a null value in there. That just means that, well, what does it mean? Does it mean that there are no credits? Is that equivalent to 0? Probably not. It means kind of unknown. We don't know it yet. But nulls can represent a lot of different things. So for instance, we might actually have, like, for instance, we might have a department over here, which we're going to basically have no budget for. All right. And it's not because it's not known. It's because in our finance system, we're not going to give them any money. All right. That's probably not very nice. Let's see if I can look for another example of where null might just simply mean not applicable. Let's say that we have no, that's not going to work. Null section ID. What would be a good example of a null? There really aren't any good examples in this database. Oh, there's a null. There is a null there. All right, so what does this mean? We have a student taking this particular course, and for their grade, we have a null. So what this means maybe is it means that student, it's possible that there's a couple of different interpretations here. One interpretation is that we haven't marked them yet. They haven't got their grade because we're in the process of marking their grades, all right? So that means that it's basically a unknown because we haven't marked it yet, right? And then there's another possibility that maybe that student was taking it for non-grade, just for, like, you know, pass fail or something. We don't, yeah. And then there's, yeah, so, but as we'll see, so when they built SQL systems, they didn't really want to get into the business of ascribing meaning to what the null meant, really. They figured, well, the designers of databases will come up with their own understandings of that. But from a logical point of view, we have to kind of be able to deal with null, like the idea of a null value from a kind of a mechanism point of view. So SQL tends to kind of just look at it at nulls from a mechanistic point of view of, like, well, how are we going to deal with it when we don't have a value? Now, what does it mean for not have a value? Well, that's up to the designers and to the people who are or interfacing this with the conceptual model of the world. But what we're going to do when we implement it, we're just going to have, you know, we're going to have a null, right? And we're not going to get into the business of having a whole bunch of different types of nulls. We're just going to have one. It's called null, right? So null values. So instead of a normal domain value, we can allow for nulls, unless, of course, we declare the column to be not null, in which case it always has to have something specified. All right, the semantics null is not specified. That's right. Okay, it's the usage convention. Okay, so suppose that we have telephone for the employee, then there are at least 3 possibilities. The value is not known, so the employee has a telephone, but we don't know what the number is. No value, the employee has no telephone, or inappropriate attribute. So basically, it's like, in this case, this is kind of a little bit of a stretch, but you have the idea of it just doesn't apply. All right. Is there any other? Yeah, these are the 3 big ones, but then you can sometimes sit there and scratch your head and come up with other maybe possible semantics. Yeah, so we already kind of entertained this question here. All right. Okay, so the SQL standard, let's just kind of a little bit of skipping around here. The SQL standard is the standard So the history of SQL, basically the way the SQL worked is that when they first developed databases in System R at IBM, they put the programming team, and I forgot his name, but there was kind of one major architect of SQL, and there were like the mathematicians who were doing kind of like more logical languages over the relational model. But it was a very pragmatic. The design of SQL was very pragmatic. The initial SQL. There were a couple other competing query languages, but SQL was the one that ultimately won out. It was developed at IBM in the System R project, and then it was taken up by the main vendors. And then what happened was that it got into the standardizations process, because the idea, of course, is that customers want to have things standardized so that they could, in principle, move from one database platform to another. If you have a lot of proprietary aspects to a language, which there still are in SQL, but if you have too many of them, customers really don't like being locked into certain vendors. They really don't like it. So there was kind of, it was kind of remarkable in a way that it actually worked, that they got it so that I mean, Oracle and IBM were the big ones, I suppose, that back in the day, that had to kind of cooperate. So they did. There's still a lot of vendor specifics, though. So most systems implement a superset of a subset of the standard specification. So the standard specification of SQL is a monster. So the SQL committees, they produce a giant set of documents that probably stack like 3 or 4 feet high in paper. So I had a friend who was actually involved with some of that. I didn't envy his. I mean, but they have a lot of power, I suppose. But it's just really grinding. I mean, just to kind of. Anyways, what was nice? PostgreSQL essentially abides by it. So you'll find, but again, like PostgreSQL. Let's take PostgreSQL and MySQL. I mean, if you implement a really full system in PostgreSQL, can you just push a button on it and migrate it over to MySQL? No. I mean, there's going to be a lot of rewriting, especially when we get to some things like the programming languages. So PostgreSQL, for instance, and we'll cover this. It has this what is it? PL/PG/SQL is what it's called. So there was a language called PL/SQL, which was developed by Oracle, which is like the kind of the server side programming language inside of SQL. And then PostgreSQL kind of adopted, for the most part, the way it looks like in Oracle. I don't know what MySQL does about it, but of course they create functions in MySQL as well. But these are all vendor specific. They're not going to be. You can't take a program written in PL SQL and then just kind of swap it into Postgres in this PL/PG/SQL. You can't do that. It doesn't work. You have to kind of rewrite out large parts of it. So yeah. All right. So the parts of the SQL standard is we have like the main part is like this. The main 2 parts are the data definition language and the data manipulation language, the DDL and the DML. So the DDL is the where you kind of define the tables and the integrity constraints, and you can also declare views. So I'm sure that we all remember what views are, right? We'll probably review them right here in a second. The data manipulation language is actually the queries. So this is where we're doing both the reads and the writes of the database. So the select and the update and the delete and the insert, right? Those are your primary ones. You got your big 4 there. Select for read queries, delete for basically deleting tuples or records. Your update, which is where you modify single records, and then your insert, where you bring new ones in. All right. So those are your main data manipulation operations. Then we have transactions, of course, and we're going to cover these in great detail. And this is basically the way that we allow for multiple users to kind of feel as if they're using the database as just by themselves, but in fact, it's being shared across many users. And this is it's always very easy if everything's just a read query. But when you have writes in there, then you can, things can kind of interweave in a bad way, and maybe somebody needs to get aborted because you put the data, you put the set of it's not possible for us to share the database, so someone's going to get kicked out, right? And then they have to restart. So that's kind of transactions. So transactions is a big deal. Then we have the whole kind of authorization part of the SQL standard, which basically has to do with like granting and revoking privileges. And yeah, so you have the idea of database users, database groups. You have the idea of these resources, and you have kind of the standard model of how you can basically give different access rights and privileges to different users and groups. All right, and add users to groups, et cetera, et cetera. So we're going to cover this a little bit. It is actually quite important. That stuff is quite important. Then we have access from host language. What language are you going to bind? So now I can ask you guys a question, because I'm kind of getting sick of hearing myself speak here. So I can ask you guys a question and get some feedback here. All right, just in the chat, maybe you can put it. What's your favorite language, your favorite host language? I mean, I can see what mine is. It's Python. Mine is Python. I mean, some of you guys are going to say what, like Java? Some of you guys are going to say C#. I hope a lot of you guys say Python. Good. Yeah, Python. Python is definitely the way. I mean, Java. Hell no, Java. Yeah, I agree. C++, C. Yeah, I mean, C and C++ are kind of good if you really need to make it run fast. Types. Yeah, I knew someone was going to talk the JavaScript stuff. Yeah, so some people like Node and JavaScript. I mean, that's kind of modern stuff. I mean, I don't know. I mean, JavaScript actually is pretty cool, I have to say. I mean, just like the way they do promises and stuff like that. I mean, it is actually pretty advanced. It's an impressive language. I mean, what they've done with it in Node. But Python is really I think you're kind of catch-all. Any other languages? C. Okay, all these languages have some kind of binding into databases, and they typically do it through some kind of cursor, right? So you have a cursor. Basically, so it's like that's why you got to connect to the database. So the database sits there as a system. You got to like connect to it, and then you got to you open a connection, and then you might open a session or something like this, and then to that session, then you can basically issue queries, which then come back as results as a cursor, and then you can kind of walk that the cursor object inside the language, and then get all the tuples out, right? So it's like some kind of iterator object that you walk. That should be familiar. Why would you need to iterate though? If I have a database in the back end, and why don't I just say I'll ask my query and just get back and just get back this giant list? Why can't I do that? Is there a problem with that? I mean, let's say I want to, let's say I have this giant query I want to run, and I want to go through every single one of they say there's this infamous or this kind of hypothetical, or I'm not really sure what the thing is. They say there's like some database out there, and it's called, they say, what's the largest database in the world right now? The absolute largest database in the world. Apparently, I'm not really sure what the story is, but this Walmart company. So Walmart apparently has one table that has every single transaction they've ever done. And apparently, they say if you do the select star on the Walmart sales table, your query is going to run like into like for the next 400 years or something. So I mean, it's not, you can't do it. But if you get big databases, what you want iterators, because you don't want that big database. When you do a query over that, it might be potentially a very, very large amount of data coming back, maybe even more than is in the main memory of the computer you're using. So what you want to do is you want to walk through, you want to grab it a tuple at a time or a record at a time. You don't want to like pull back the full list, because that'll crash your program, right? So if you're talking about big databases, then that's one of the reasons why you have iterators. But anyways, that kind of stuff, like defining that, where am I? There's a lot of definitions about like accessing from different host languages. Okay, so that's part of it as well. All right. So actually, there's quite a bit more to SQL. I'm not really sure, but the SQL standards. I mean, if anybody's really interested, I can, you can go and do a search and find the standardization documents if you want to have some enjoyable reading. One thing that I thought was going to be here that I just need to, well, there's also the server side language, like the persistent stored modules. PSM is what it's called. That's kind of an important part. But anyways, all right. So defining tables. This should really be review for everybody. But I mean, I'm assuming that everybody in this course has done a create table command. I mean, if not, then you really got to ask yourself what you're doing in the advanced database course. If you haven't done a create table command before, then I don't know what to say, except that you probably should take the database 1 class before you take this class, because you should have at least had some experience, at least seen these. I mean, so anyways, I mean, this is part of the DDL, data definition language. So it's kind of standard create table, and then you can say the primary keys here, and you can also put in check constraints, which put constraints on, like the budget has to be greater than 0, right? So if you try to insert a tuple that has a budget less than 0, budget of negative something, then it'll block the insert, right? Foreign key right here. Here's a foreign key reference. Okay, so there's our foreign key from the department name. This is a foreign key into departments. Okay, here's a little more. Not null constraints, right? So we always have to have a per show number. We don't allow anything in without a per show number. And then we also have unique. But do I see a unique here? A good example of unique is like an email. So emails are kind of very commonly unique. So basically what it says, yeah, you can insert a student here. Maybe I don't see an email here, but you could say I insert a student, but they have to have a unique email, so that we don't have, because everybody does actually have it unique. All right, excuse me. Let's see. So a lot of times, if you need to, you can use the alter commands, which you can add constraints kind of after declaration, right? So, and you can take them away as well, right? So that's. I mean, this of course becomes. It depends on kind of what the use case is, but sometimes if you have an existing database, you can't always rebuild the database from scratch. Although it's a good idea to have the capability. So sometimes you need to actually kind of like in place, kind of start monkeying with the database. So that happens sometimes. And you need an alter for that. All right. So the basic form of a DML select query or read query is select the attributes from the tables where, and then you have the conditions. So this should all look very familiar. So you can list out the attributes, name, salary from instructor. That'll give you back a table with 2 attributes. We'll give you back something in the form of a table with 2 attributes. It's not a table per se. It's the result of a query, which is tabular, but it's not a table. Star will do that, but it'll just kind of go over all the attributes here. And then we have simple conditions where we can say the department name equals comp sci. Or more likely what you'll see like this will be all lowercase here, and you'll put a lower over department name. So you force everything into case and sensitivity on the condition. You can put aliases in, which give the headings on the table different names. So this again is I'm sure that you guys have all seen this. Or you can do order by, right? So you can put things in an order, and descending or ascending, and you can order, of course, by multiple attributes. All right. So then there's the issue of joins, where we have 2 tables. So in this case here, we have getting the building. We're basically getting here the buildings and the names of the instructors in that building, getting from department and the instructor, and we're doing the join here on that the department name has to equal the instructor's department name. Okay, so this this kind of join is kind of like you're doing the join. You can do the join in 1 or 2 places. You can do the join in the where clause, or you can do the join in the from clause. So you could actually have here department join instructor on, and then you say department name equals dep name. Dep name equals dep name. Or you say department as X, join department instructor as Y on X.dep name equals Y.dep name. All right. So you've seen that alternate syntax to specify the join actually in the from clause. Now, SQL likes it a little bit better if you do it that way. The reason is it gives the optimizer a bit more of a chance to identify the join going on. So a lot of times what you'll find that putting it on the front line leads to better performance. All right, but we'll talk about that later on when we talk about performance. How it can use indexes and stuff or how the strategies it uses to actually execute the query. All right, so yeah, here's an exact example. There we have inner joins. So there's the notion of an inner join, which basically means that, well, things have to find a match, otherwise they don't get included in the result, or an outer join, which will pad things with nulls, which is another case of us using nulls in a weird way that are kind of semantically, God only knows what they mean. But outer joins is where nulls get brought in as well. All right. So yeah, the natural join. So this should all be just really reviewed. If there's any questions, just type them in the chat because we're gonna blast through this. Natural join basically says, well, all the attributes that are the same thing, that have the same, all the columns that have the same name, there's a forced equality on those. That's what a natural join will do. All right. When you do a self join, you need to use aliases. So if I'm going to join department with department, then I need to have an alias. Otherwise, it doesn't know what to. It can't. Otherwise, any column reference becomes ambiguous. Theta joins, yeah. Theta join just is kind of a fancy way of saying that it doesn't just have to be equality. It can be a different operator, like not equal to or greater than or less than or something. Sets and bags, right? So if you recall, SQL is under bag semantics, not set semantics. So there can be duplicates, and that's for efficiency reasons mostly, because you don't have to go and remove duplicates if you're dealing with bags. So under the bag semantics, I mean the usual operations apply to bags. So the union and the intersect and the difference apply to bags. But you can force it so that by just in the syntax union all, you intersect all, that it will go to a set semantics. Okay, I'm wrong there again. Sorry. Generally speaking, what will happen? The set semantics will actually, when you use the set operators, it'll actually go over to set semantics. It's like this quirk in SQL where you have to actually turn. If you want to get bag semantics on the set operations, you have to actually then you say all. So it's kind of it's a weird inversion, but. It comes up when it comes up. Embedded subqueries. Yeah. So you can play these games. I mean, there's a lot of, SQL is kind of a little bit, it's a little bit underdetermined. So, these people who talk about types and stuff like that, like a type, it's not type safe at all. It's really kind of actually pretty bad. So a query like this, actually, strictly speaking, right here, look what we have here. Select star from instructor, sure, where the department name equals, and then it's getting the department name where there's an instructor named Srinivasan. So let's say that instead this name was Smith, and there was two Smiths working in two different departments in chemistry and biology, then this thing returns a set here, and you can't have department name equals a set, so it busts down as a runtime. It does a runtime bust down. Runtime it barfs because two values come back here, and it gives up the ghost and chokes on that. Throws an exception. That's really bad, actually. This is really bad practice, by the way, to say equals here. It's really bad because, yeah, sure, if it gives you back one, then it's going to work, which is, can you guys see that it's based on the data state? This thing can sometimes work and sometimes not work. That's kind of the key point here. And it's bad, bad, bad. Yeah, there's lexical scoping. So you don't have to alias instructor here because you get lexical scope. In other words, this name here is talking about the one that's in the tightest scope. It's the instructor in the tightest scope here, right? You get that? So you get that. So, but this is just, this is an awful way to do things. This is a little bit better. You're doing an in here. So this is a bit more robust in terms of, you can tolerate having a set here that comes back. But the idea that you can kind of splice in queries where values are, or where sets are, that it kind of has this kind of, you can have subqueries in SQL, which is nice, but can be abused. Existential quantification, yeah, so you have the where exists. Let's see, that is in. Right. So you'll get queries where you say where exists, where something exists, and those generally speaking are not so efficient. Just as a, you can do intersections. What do we got here? Yeah. Intersection, except is the minus. And then, yeah, then there's the whole idea of doing universal quantification. You can get it by two embedded not exists. I went over that in the database one course pretty extensively, and you can also do it with aggregation. Then we have these. These are not so popular, but you'll see them sometimes used, all and any. But generally, I would try to stay away from these kind of more exotic operators. But the idea here is where the salary is greater than, and then if you get the salary from the instructor, greater than or equal to, of course, all of them. So it'll do a, it'll basically, this has to be true for every single one of them. All right, and then any just means there has to be one of them. All right. So now we get into this, into aggregate operators, which, I mean, we're not going to go over this in so much detail, but I mean, I just want to, the slides are there. Go through the slides and make sure you understand you can do all of these, because this is basic stuff. But the for recitation one, you're going to be forced into doing some kind of complicated aggregation. So we'll suss out whether you can do it or not. But basically, the idea is to understand how the groups work. So this maybe is, all right. Grouping by department. And let's see if we get another one. Mission of group by. For each department, find the maximum, minimum, and average salary, as well as the number of employees. All right. So this right here, where it's doing a, what this is doing right here is that if there doesn't exist, where not exist, this second here, this union here, is just a way to put these literals 0, 0, 0, 0 as the minimum, maximum, and average salary. Minimum, maximum, average, and then the number of employees. Those are all zeros when we don't, when it does not exist, when there is no instructor for that department. Okay, so so this second part here, the select department name down to, yeah, this thing right here. I hope you guys see what that's doing. It's just kind of putting in the kind of the corner case here where there are no instructors. This is the main query here, though. But it's nice to see that you can do this, because this might, I mean, this is where you're packing kind of the, I mean, whether this will actually come up, God only knows, but it's where you're getting the SQL to kind of like give you a complete answer that has the corner cases dealt with as well. This might actually come in handy somewhere. But what it shows you is you can actually splice in just literal values, which is nice to see. 0, 0, 0, 0. Anyways, this is the main query here, where you're basically saying, okay, the department name, and then we're getting the min salary, the max salary, the average salary, and the count. And we're grouping that by department name. So what it's doing is going to instructor, and it's basically saying if there's 20 different departments, but there's like 500 instructors, it's going to form 20 different groups, right? What the grouping does is it's just going to partition the tuples or the records in that table into the 20 different department groups, right? And then over each of those groups, it's then going to do the aggregate function. And aggregate functions have a very technical type, and that is that it's from vector of values to a single value. That's what min. What does min do? It takes in a vector, right, of salary values for each of the instructors in one particular department, because that's what it's being grouped on. And then it's going to basically find which is the minimum. Likewise, the max, likewise, the average, likewise, the count, in fact. So it takes in a vector and it does the count, but it's how many elements are in the vector, right? So just understand that the aggregate function is always taking a vector of values and then computing a single value. That's what aggregate functions do. That's the type of an aggregate function. Okay. Aggregate operator, I meant to say, not an aggregate. It's a function too, but it's an aggregate operator. Let's call it that. Let's call it that. If you omit the group by, then it's just going to do it over the full sheboygan. It's going to do it over, like this is over the whole, there is one group. When you omit a group by, you still have a group. It's everything. One group. So this is getting the min, max, and okay, all that. This will not work. And the reason is because you don't have an aggregate function. It's kind of the department name doesn't know what to do with the department. If it doesn't have a group, it doesn't know what to do with the if it's not grouped on it, it doesn't know what to do with it. So everything has to be aggregate function. So I hope that you understand why this fails. But SQL is good about making that fail. All right, the halving is something that gets it's a condition that can be specified over an aggregate operator. So in this case here, where the count of the things in the group is greater than 2. Right. So why? Oh, I'm sorry. This is it's a halving. You can't do this as a where, because the where is just going to go on a tuple by tuple basis, and this hasn't been calculated yet. So you can't do it as a where. Instead, you can do it as a halving. So you need the halving if you want to do it in one crisp form. Now, do you really need the halving? Can't you do subqueries? Yes, you can do subqueries and get the halving. Logically, you can get something equivalent. So from a logical point of view, halving doesn't add anything, but you want to have halving, because to have halving means that the query optimizer can apply it in a much more efficient way, right? So halving is, you want halving. You need to have it in the language, but logically, you can simulate it, but you don't want to simulate it because it'd be much more inefficient. I hope that makes sense. All right. All right, then we get to pattern matching. And we're actually going to touch on this quite a bit late. We're going to touch on this later in the course, because you have the like and the I like, which is the case insensitive version of it. You have like, which is really old fashioned, really grubby. It's a really grubby way of doing things. And then you have the similar to. This is all similar to is actually okay, but what you want to do is you want to use. Let's see, do I have it here? No, I don't have it. We're going to touch it in the later on in the course. But what you want to use the regexp capability inside of SQL and PostgreSQL in particular. So we have, sometimes, I'll confess. Sometimes I use like because it's so easy to do, and it covers such a general case. But strictly speaking, what you want to do is you want to use regexp. Regexp is, as we know, is much more modern way of doing things. By the way, you guys should know, or you will know in this course, we're going to cover regexp. That's Jesus. You got to know regexp. That's like really, again, these are the basis of interview questions. If I was going to interview somebody for a job and they didn't know regexp and they were a computer scientist, I would no. I wouldn't, no. You need to know regexp. All right. All right. All right. So now we're going to talk. Gosh, we're going to make some progress here. 2 minutes. All right, let's go. Basic update operations. So we have it's called the IDM model of updates, insert, delete, modification, which basically corresponds to insert, delete, and update. So these you can actually get everything to kind of basically work with those. It's like this idea of like CRUD, like a CRUD application. What does CRUD stand for? CRUD. You guys have seen this? CRUD. Create, update, and delete. All right. So this is so when you talk about a CRUD application, it means this. You kind of cover. You can have these. IDM basically can cover CRUD. All right. Inserts with the values. There we are. Fairly straightforward. Delete, likewise, if the condition's met, the tuple goes. Update, set, where, and then a condition, and then you set a column to a value. Yeah, so remember, there's also, so a lot of times these things operate at the periphery in database systems. You have these tools that are kind of bringing data in, and they do a whole series of inserts. You can also do select into, which is really nice. So if I have one table and I have another table which is empty, I can do a complicated select query. And if I just say all that, and then I say into, and I name the other table, then it does a whole bunch of it'll do the one query on that base table, and then it'll insert everything into the other table, which is kind of nice. So that's another way that you can kind of populate your tables is the select into statements. So when you see insert, you'll see that happens quite a bit. Delete, update. All right. Multiple updates and integrity constraints. So sometimes you get into these chicken egg problems with the. Okay, we'll cover this later. We'll cover. We'll resume with this on Friday. So yeah. So if there's any questions, just put them in the chat at this point. But otherwise, lecture is over. Hello. Hey. Yes. Yeah. Hey. Okay. Kan du vänta 2 minuter? Jag måste vara färdig med någonting. En stund. Ja, 2 minuter. En stund. Sorry. Okay, guys. Well, are there any questions, or because I can just stop the record at this point? Okay, sorry about the end there. I got a call. All right, let's see. I'm going to stop the share, and then I'm going to stop the record. Okay, see you all on Friday.